So, I can get all 6 of them in there. Look at that, I can. Sweet! Alright, so, anybody match any of them up? What do you think? Give me one of them, Bryce.
I think F is the F of X equals 10 to the power of X.
10 to the power of X?
Yeah.
Okay.
I think that's what that is.
Okay. How did you come up with that? Just give me a little, walk me through the rationale.
Well, 10 to the power of 0 is 1.
Okay.
So 0.
So that one went through the point 0, 1.
Yeah.
Okay.
And then the next one would be 10 to the power of 1 would be 10, so 1 and then 10.
So then this is the 1, 10. So you're saying that this is f of x equals, what was it?
10 to the power of
10 to the power of
X.
x. So this one down, this middle one on the top row we said was f. Okay. Anybody want to disprove it? Okay, I think we're good there. Somebody else give me one. You already just did one. Kevin, give me one.
I say 2/3 to the power of X is A.
Is A?
Yeah.
2/3 to the power of x is A. 4, 2. Okay, so then walk me through the rationale.
Since it's a bigger fraction, it will go slower.
It will what do you mean it will go slower?
It's not as steep as a curve.
It won't decay as fast?
Yeah.
Is that what you're trying to say? Okay. So what points would it have to go through?
1.
1 isn't a point, 1's a number.
0, 1.
0, 1. Okay. So this one goes through the point 0, 1. Okay. What other points would it have to go through?
0, 2.
No.
Wait.
Then it's not a function if it goes through 0, 2
1,
thirds.
1, 2 thirds.
1, 2 thirds. So that's that one right there then, right? But this one also gave me another one. Gave me a -1, comma, what would it be what would the value of this function be at -1? 1.5. 3 halves. Okay. So we're saying that this one is f of x equals 2/3 to the x power. Okay, give me another one. Go ahead, Bryce.
F of X equals 3 to the power of X would be C.
Well, which one was it? 3 to the power of x?
Yes.
Okay.
Would be C.
Would be C. Okay. Rationale?
To the power of 0 would be 1. 0, 1. And then also, 3 to the power of 1 would be 3. And then 3 to the -1 would be 1/3.
So you're saying this one is f of x equals 3 to the x. Yep, I would agree with that. Anybody else want to disagree? So that one we said was C. Okay, 3 more to go. Megan, I see that you've got yours all filled out. Pick one of the other ones and justify it for me. E was 0.1 to the x power. Okay, what was your justification?
I just want the closest to the lines that had the steepest.
Okay. Why would you just spitballing here, why would 0.1 to the x have to be a steep decay? Not going up by 0.1 every time. Multiplying by what? By 0.1 every time. So that's going to be we're only keeping so if you got $1, right? And you multiply it by 0.1, you're only keeping 10 cents on one multiplication. And then on the second one, you're only keeping 1 cent. You know what I mean? So that's going down rapidly in two, you know what I mean? Yeah. So that's justification there. Yeah. Okay. Alternative justification would be it would have to go through the point 0, 1, and it would have to go through the point -1, 10, and it would have to go through the point 1, 0.1. Right? Okay. So this would be f of x here equals 0.1 to the x power, which was this one. Okay. 50-50 shot for anybody. It's either going to be 1.5 to the x or it's going to be 1/3 to the x. And we can use some alternative justification here. Anybody? 50-50 shot. Somebody that hasn't answered yet. Sorry, Bryce. Sorry, Megan. Sorry, Kevin. 50-50 shot. We're looking for f of x equals 1.5 to the x and f of x equals 1/3 to the x. We got Josh.
1.5 to the power of x would be b.
Why?
Because, first of all, it has to equal, 1.5 to the power of 0 would have to be 1, so that's correct.
Okay.
1.5 to the power of 1 would be 1.5. And 1.5 to the power of -1.
Could be what?
Would be not -1.5.
Not -1.5. No.
Would be 0.6.
No. It wouldn't. It'd be what, Kevin? It'd be 2/3. Because 1.5 in fraction form is 3/2. Okay? So what 3/2 to the -1 power, we flip that fraction is 2/3. Okay? 0.6 is 3/5. Okay? They are not the same. Okay? And you can't tell me that they are in any justification. Okay? Alright? So f of x here would be, this one would be 1.5 to the x. So that's b. Now, well, actually, I'll get into that in a little bit. So then that means that this one down here is d, and the justification here would be it goes through the point 0, 1, it goes through the point 1, 1/3, and it goes through the point -1, 3. Okay? With me? What I would like you and a shoulder partner to do now is I would like you to do number 2, A, B, number 3, and number 4. So 2, A and B, 3 and 4. I'll give you 10 minutes to go over those 3 questions. Shouldn't take you that long, and then we'll discuss them as a class. So, one thing that we're going to talk about in this chapter is we're going to talk about exponential functions. Okay? Now, the basic exponential function is f of x equals a times b to the x power. Okay? So that's what we're going to be referring to when we go through here, because it'll make it be a little bit easier for you. Okay? All right, so let's have a discussion now on what point does every single one of those 6 graphs go through? 0, 1? Okay? All right? Because 0, 1 to me is the number that's on the side of the general lead in Dukes of Hazzard. Okay? All right? 0 comma 1's a point. Okay? So they all go through the point 0 comma 1. Now, here, you guys are probably too young to even know what the $64,000 question is, but because I'm even too young for it. Back in the 60s and 70s, there was a game show on TV called the $64,000 question. And it was you answered all these questions, and then the last question you answered was for $64,000, if you got it right all the way up to that point. Okay? Why do all of them go through that point? He did, you know what? Tap all of your brakes. Talk to me, Lauren. She hasn't answered yet, that's why.
Anything to the power of 0 is 1.
Anything to the power of 0 is 1.
Even 2/3 more?
Even 2/3. Okay? All right? And so all of our functions here had an a value of 1. Right? In all of our functions, our a value was 1. So that basically came out of the equation. Right? So we just had b to the x. And as Lauren just said, anything to the 0 power is 1. So 10 to the 0 power is 1. 2/3 to the 0 power is 1. 1.5 to the 0 power is 1. 1/3 to the 0 power is 1. 3 to the 0 power is 1. And 0.1 to the 0 power is 1. Okay? So love it. Okay? Part B. Compare the equations. So now we're just looking at the equations. Compare the equations of the 6 functions we just sorted. What differentiates a growth from a decay? What differentiates a growth from a decay? A growth function grows as you're going to the right. A decay function, this is shocking, I know, decays as you go to the right. So what differentiates between those? What do you got, TB?
For growth, it's going to be b equals the number greater than or equal to 1.
Can I take out 3 words from your thing? Okay. I'm going to take out or equal to. Okay? All right? Because if it's equal to 1, then it's just going to stay constant all the way through. Never going to grow. Okay? All right? So here, we're going to have b values that are greater than 1. Okay? What makes it a decay function? What do you got, B?
When 0 is less than x and x is less than 1. Right? If you
No.
and that's the integer.
No.
Less than or equal to.
No.
Less than.
No.
Well, Ruby, the b value has to be between 0 and 1.
I like the b value has to be between 0 and 1. You said x. Okay? Yep. The b value here has to be between 0 and 1. But not equal to again. Okay? Yep. Can't be equal to 0, can't be equal to 1. Wink, wink, nudge, nudge. Okay? Question number 3. Sarah and Scott's teachers asked them to each write a rule that would determine whether a function was a growth or decay based on its equation. Sarah said, for exponential growth functions, b is a value greater than 1, but for exponential decay functions, b is a fraction or decimal between 0 and 1. Okay? That's what we just said. Okay, reading ahead should have been able to go back and answer that question for us. Scott said, for exponential growth functions, b is greater than 1. For exponential decay functions, b is less than 1. The question that I have for you now, or that you actually already discussed, is why is Scott wrong? Why is Scott wrong? I want to. Honestly, I really do. I want to call on you, but I also want to get everybody involved too. You know what I mean? Okay. So Jacob, why is Scott wrong?
Because if you say it's less than 1, you could say it's negative, and it has to be between 0 and 1.
Okay. What happens if it's negative? So, like, give me a counter example of with a negative b value. F of x equals
You just say negative 4 to the x power.
-4 to the x power. Okay? Now, I'm going to pause for the cause. While we're paused for the cause, we'll fire up the old Inspire Calculadora, because then we'll see this picture. It's a pretty cool picture, actually. Okay? So, close. I want to go 200, because it makes it nice and pretty. And I want to add a graph. And you said, Jacob, you said -4, correct? To the x power. Okay? Ready for it? Whoa is right. Yeah. I'd rather not. Okay? Because what's happening is every time you go to an odd exponent, it becomes negative. The value of the function is negative. Even exponents make it positive. So it keeps flip-flopping. Okay? And I don't like flip-floppity flu. Okay? 2. I learned this the other day. Oh, whoop.
Nice.
Gotta get on the pointer. 2 fingers make it paste. Okay? And so that's not good. Okay? That's why we gotta be positive. Okay? Question number 4, the last question. What b values in exponential functions produce neither growth nor decay functions? What? 1? Okay. A b value of 1 would not produce 1. So let me go back here into this and into here, and let me go to there, and let me go up 1, and let me go in there, and let me go 1. Okay? With me? Oh, now? Why won't it let me? There it goes. Oh, nobody better be packing up yet. That's naughtiness. Okay? And what's the other one? 0. Okay? Come on now. There it is. Tab. Up. Oops. Equals. Whoa, what the heck's going on there? I don't know what's going on there. But let me escape out of there. Tab up there. But 0 would also not give me 1, 2. I'll put it on the notes then for you. Okay? Alright? So 0 to the x would only give us positive values there. So that's why it doesn't work. We'll pick up on this tomorrow.
What about 0 to the 0 power?